So here's an example. Jill spent X dollars on pet toys and $12 on socks. If the amount Jill spent was twice the amount she earns each week, how much does Jill earn each week in terms of X? So lots of things here that tell you that this is a plugging in question. There are variables in the answer choices. The question is in terms of X. These are all little triggers that tell you that you want to use plugging in. So what you do is you pick something for X. You want to pick something easy. So how much do you want to say that she spent on pet toys? $2. Okay, so we'll say that Jill spent $2 on pet toys. So we're saying that X is 2. And $12 on socks. If the amount Jill spent, so how much did she spend?
$12.
She spent $12 on socks and $2 on pet toys. So how much did she spend? $14. The amount she spent, that's $14, was twice the amount she earns each week. So how much does she earn each week? $7. How much does Jill earn each week? Okay, so we just said she earns $7 each week. So now what you do is you take the number that you chose, we chose for X to be 2, and you plug it into all of the answer choices until you find the one that gives you 7. So if I plug in 2 here, 2 plus 12 is 14, times 2, that's not 7. 2 times 2 is 4, plus 24, that's not 7. 2 divided by 2, that's 1, plus 12, that's not 7. 2 plus 12, that's 14, divided by 2, that's 7. Okay. So the answer choice that you would pick would be D. Okay, this is one that's pretty easy, and I know some of you math, algebra people would look at that and go, well, duh, it's X plus 12 divided by 2. But not everybody sees it that way, and if you'll practice this strategy on these easy ones, then on the harder ones, which we'll see in a second, you'll be better at it. Okay, so even if it seems easy, use this as an opportunity to use plugging in. So does that kind of make sense, that you pick a number? Okay, so let's look at another one. Okay. Carl bought X bags of red marbles for Y dollars per bag and Z bags of blue marbles for $3 per bag. If he bought twice as many bags of blue marbles as red marbles, then in terms of Y, what was the average cost in dollars per bag of marbles? This is really confusing. This is a really good one to use plugging in on. Notice again, we've got the whole in terms of Y, we've got variables in our answer choices, so this is all telling us to try plugging in. Okay, this one's a little bit trickier because there are some rules about the relationships here. So we have X bags of red marbles, and they cost Y dollars per bag. And then we have Z bags of blue marbles that cost $3 per bag. And there's one other thing we have to make sure of. It says he bought twice as many bags of blue marbles as red marbles. So we have to make sure that Z is twice as much as X. He bought twice as many bags of blue as he did of red. So Z needs to be twice as much as X. Okay, so how many bags of red marbles do you want to say that he bought?
4.
All right, we'll say 4. And how much do you want to say that they cost per bag?
2.
Okay, we'll say, I heard 2. We'll say $2 per bag. Okay, which means that Z has to be what? 8. And he has to have spent 3 times Y. Well, we said Y was 2, so 3 times 2, those had to be $6 a bag. Alright. So really, we could pick X and Y, but then there were relationships for Z and 3Y that we had to follow from the problem. Okay, so then it says that in terms of Y, so Y is here, right? Y is what we're going to be plugging in. What was the average cost in dollars per bag of marbles? So how do you determine average cost?
Have them
Add up the total cost and then divide by how many bags there were. So how much did he pay for the red marbles? $8, right? Plus, how much did he pay for the blue? 48. And altogether he bought 12 bags, right? So that's 56 divided by 12. Oh, I should have told y'all to get a calculator. You can get up and get one in a second. So 56 divided by 12. It's like 4 with a repeating. Yeah.
Wait, how'd you get 12?
Because there were 12 bags, right?
Oh, okay.
Yeah, it's like this. 4.66666 repeating. Right. So this is what we're trying to get when we plug in 2 for y. So which of those is going to give us that when we plug in 2 for y? Right? Because these are all in terms of y. So if we plug in 2 for y on the first one, that's going to be 6 over 2, which is 3. That's not right. If we plug in 2 here, 14 over 3. That is 4.6 repeating. This one would be 4. This one would be 4. This one would be 12. This is the only one that even gives you a decimal. All the rest of them, if you plug in 2 for y, right? Because these are all in terms of y. We said y was 2. So it would be B. Okay. That one's still kind of tricky, but not nearly as tricky as it would be if you didn't use plugging in. Does that make sense? Okay. A different kind of plugging in example. At his bake sale, Mr. Huffwhistle sold 30% of his pies to one friend. Mr. Huffwhistle then sold 60% of the remaining pies to another friend. What percent of his original number of pies did Mr. Huffwhistle have left? Okay, the gotcha answer here is to say 10%. Because people look at this and they go, well, he sold 30%, and then he sold 60%, that's 90%, so he's got 10% left. But remember, all 30% are not created equal. All 60% are not created equal. It depends on if they are 30 and 60% of the same thing. This is 30% of what he starts with, but this is 60% of what he had left after he sold those 30%. So it's not 30 and 60% of the same thing. So what you want to do is pick an amount that he started with. How many pies do you want to say he started with? 100. With percents, 100 is a really good number to pick, and we'll talk about good numbers to pick here in a second. All right, so let's say he starts with 100 pies.
Deanne Cook, please dial 8112. Deanne Cook, please dial 8112.
Then he sells 30%. Well, 30% of 100 is 30. That's why 100 is a good one to pick, because percent means out of 100, so 30% means 30 out of 100. Since we chose 100, that's a good one. So he sold 30. He's got 70 left. Then he sells 60% of those. We're going to talk more about percents later, but the way that you find 60% of 70 is you say 60% of 70. So you do 60 out of 100 for 60%. Of means to multiply, and then 70. We'll get 42. So now he's got 28 left. 28 out of the original number was 100. 28 out of 100 is 28%. Okay, so this is a good one to plug in on because it asks you about percents of an amount, but they don't give you the actual amount. So when you see a problem that involves percents or fractions of an amount without giving you any actual amounts, then you can plug in. Pick a number and plug in. Okay, so I think it's time for okay, so some tips for plugging in happiness, and then we do a quick quiz. You want to pick easy numbers like 2, 4, 10, 100. The best number to choose depends on the question. 100 is really good for percents. We just saw that. Avoid picking 0 or 1 because weird things can happen with those, or any number that shows up in the answer choices. If the number you pick leads to ugly computations, you get a bunch of fractions or negatives or anything that you need a calculator for, bail out and pick an easier number. And the best way to get good at this is to practice. So that problem set that I gave you at the back of this packet over plugging in, those are going to be really good ones for you to practice this strategy on. Okay, so the last thing we're going to do today is a plugging in quick quiz. So if you look in your packet, you'll have to flip over a few pages until you find where it says quick quiz number 1 up at the top. It'll look like this. I'm going to give you about 5 minutes to work on these 3. Notice that there's one easy, one medium, one hard, and look at the problem numbers. They're kind of numbering them so that you get used to seeing the right problem numbers. So I'm going to give you about 5 minutes to work these, and then we're going to go over them, and then we'll be done for today. And we'll do the rest of this packet tomorrow. And I am recording these, so if for some reason you're not able to make it one day, I'll show y'all here in a minute where you can go online and find the videos so that you can watch the video at home. So I'm going to stop this for now.